6.3 Numerical model. Linear motion is motion in a straight line. It's the most basic of all motions. Objects will continue to move in a straight line until they are stopped. Under everyday circumstances, gravity and friction combine to bring objects to rest. Linear motion is measured in two parts, speed and direction. Together these make up velocity. Linear motion is not often used as a starting point for mechanisms. Scalars and vectors. These mathematical quantities that are used to describe the motion of an object can be divided into two categories. The quantity is either vector or scalar. These two categories can be distinguished from one another by their distinct definitions. Scalars are qualities that are fully described by magnitude alone. Vectors are qualities that are fully described by their magnitude and direction. Speed is how quickly a body moves. It is measured in meters per second. Velocity is how quickly a body has moved in a resultant direction. It is also measured in meters per second. Distance is the sum of all movements regardless of the direction. For example, the route the athlete or object takes as a value. Displacement is the straight line distance from start A to B in a particular direction, and acceleration is the increase in speed. Distance and displacement. This shows that the distance will go the exact way that an athlete maybe travels in a game, whereas displacement is literally from start to B in the quickest possible way. Newton's laws. Newton has three laws: inertia, acceleration, and action-reaction. Inertia. The first law states that everybody continues in a state of rest or informal motion in a straight line unless compelled by some external force to act on otherwise. Inertia is the property of a body by the virtue of which the body remains in rest or in continued motion unless some external force is applied. This is called the law of inertia. For example, a passenger falls forward when a bus suddenly stops. The passengers are in motion due to the first law, and as the bus stops suddenly, due to inertia, the upper body opposes the force and continues to remain in motion. Acceleration. Newton's second law of motion states that the rate of change of momentum is directly proportional to the applied force that takes place in the same direction as the applied force. Momentum is a property of a body possessed by the virtue of its mass and velocity. It is the product of the mass of the body and its velocity. In the case of a fallen apple, the apple is accelerated, so the velocity changes as it's hanging on the tree and moves towards the ground. Also, in Newton's second law, there must be a force that acts on this to cause the acceleration. If we use gravity, then the associated acceleration is acceleration due to gravity. If we change this example to a person, if a person jumps to receive a ball, for example, the acceleration off the ground has changed, therefore the velocity of them in the air has changed. They come back down towards the floor after a certain amount of seconds due to gravity. Action and reaction. This law states that in every interaction where the pair of forces acting on the two interacting objects, the size of the force from the first object equals the size of the force in the second object. The direction of the force on the first object is opposite to the direction of the force of the second object. Forces always come in pairs, equal and opposite action-reaction force pairs. For example, in the picture, the first action of the boat being moved away as he's stepping out, it will equal the force on the second object, which is the person, which will make him fall forward. Centre of mass and instability. The centre of mass of an object in a space is the unique point where the weighted position of the mass of an object sums to zero, or the point where If a force is applied, causing it to move in a direction of force without rotation, the distribution of mass is balanced around the centre of mass, and the average of the weighted position coordinates of the distributed mass. This is shown by the all under the skeleton. Stability is a measure of how likely it is for an object to topple over when being pushed or moved. Stable objects are very difficult to topple over, while unstable objects topple over very easily. Stability of an object is affected by two factors: the width of the base of an object and the height of the centre of the mass. Objects with a wide base and low centre of mass are more stable than those with a narrow base and a high centre of mass. Method of collecting data for this numerical model. When we went to Chichester, we were instructed by the man about what we were going to do. The instructions were given to the participants on what they were going to do and how they were going to do it. They should be clear and the exact same to both, otherwise it wouldn't be a fair test. So if he gave one set of instructions which are slightly different to Aaron than compared to Charlie, then the jump height would differ as they thought the technique was different. Before this happened, they had to complete a parkour. This is a consent form which allowed Charlie and Aaron to take part in the jump test. It also checks their medical history so that we know that they are capable of participating in this experiment. Before they were allowed to do the jump, they had to do a warm-up. Two boys were told to do a warm-up to avoid injuries that they could get during the jumps. This could also affect the jump height if they experienced a slight twinge in their muscle as they were doing it. The protocols of the experiment. In the lab, we will use a force plate to assess the ground force reactions in some motions which are commonly performed. We chose the rebounding jump in basketball. Similar to a scale, a force plate measures the force exerted by the ground in the opposite to the weight on it, so the person. However, a force plate is also able to provide information about the forces exerted parallel to the ground and the location of the force vector, so how high you can jump. We had three conditions: 45 degrees jump, a 90 degrees jump, and a counterbalance jump, and we got different measurements for each. We used a goniometer to measure the angle. However, we don't know if this worked, as each of them may have moved slightly to get a more comfortable position before they jumped, and after the last two jumps it may be down to fatigue. Also, the move itself, down to contraction, could have got added like movement or force during the isometric and concentric contractions. The added movement may have come from the concentric stages of the muscle as it gets shorter than the movement may have been added. We recorded each jump as it happened. We used 2D settings. And a side-on approach to see the planes of motion that the movement happened in. We had to make sure that each of them were wearing appropriate clothing so that we could see the points on their legs, which we could create angles from, and have to make sure the whole body was in frame so we could see the whole movement of the jump. Planes of motion. There are three planes of motion. The sagittal plane. The sagittal plane passes through the body, front to back, so dividing it into left and right. Movements in this plane are up and down movements, or flexion and extension. The frontal plane divides the body into front and back. Movements in this plane are sideways movements, called abduction and adduction. Transverse plane. This divides the body into top and bottom movements in this plane are rotational in their nature, such as internal and external rotation, pronation and supination. The atomical neutral. This is the starting point for any described movement. It is standing upright, legs together and knees straight. Toes pointing straight forward, arms side by side and palms facing forward. During our jump of the rebound, the boys would have been in the sagittal plane. This is what we recorded on the video.